Look, once again, this is a continuation where we had covered the first four questions. Now we are proceeding to the fifth one. So let me unlock the screen so we look at the question. All right. Um, Try and select reduce a bit. We are given a pattern that is formed by three congruent rectangles. Now, each rectangle is a rotation of 90 degrees around one vertex of the rectangle next to it. Now, the point A has coordinates 2 and 5, point B has coordinates 4 and 1.5. So work out the coordinates of point C and point D. Now, I'm looking at the shapes that we have here. These are rectangles. Then, as usual, for a rectangle, what we know is the x-axis, which is going to change as we move horizontally. So it means the coordinates are going to be 4 and 5 because the y does not change. Um, then when we move backwards here, we are going to have coordinates 2 and 1.5. Right. Now, looking at this distance here, which is the width of our rectangle, if we look at the width, looks like the width is 2 units. So what it means is along the y, if I'm to go down, this point is going to be 4 units along the x, because we haven't moved in the x-axis. But then against the y, we'll draw by 2 units, implying the coordinates are going to be 4 and 3. Then, as we are moving along this way now, what's changing this time around is the x. The y is going to remain fixed. So in whatever we do, we know the y is going to be having a coordinate 3. So what happens with the x? The x is going to go along the length or the bigger side of the rectangle. But now if I check here from 5 to 1.5, it looks like we have a difference of 3, whereby if that 3, I'm to add it to 4, that's 3.5. If I'm to add it to 4, then it will give me 7.5. Then along this line, our y is still 5, but for the x, we are saying we are adding 3.5, so it will give us 7.5 again. Um, then what comes next? I've got a width here of, we saw that our width is 2. So width corresponds to the x. So from 7.5, if I move 2 units, it means I'll be at 9.5. Against the y, which doesn't change, it will still be 3. Then going upwards this time around is the y, which is changing. And the y, when it changes with 3.5. So if I add it to the y-axis, then it means these coordinates are going to be 9.5 against 6.5. So I found both coordinates of C and of D. So let's try and have a look at what comes after this. Each week, Nisha is paid $12 per hour for the first 40 hours that she works. She is paid 30% more per hour for any extra hours that she works. One week, Nisha works for 45.5 hours. So the idea is we want to calculate how much she's paid in that particular week. So what we'll do is we are going to build a calculation 45.5 minus 40. It gives us the hours that she works extra. And for those hours, it's going to be above 100% by 30. So that's times 1.3. And it's 1.3 of the normal $12 that she earns per normal working period. So we also need to add for those 40, we multiply by 12. Let me try bring my calculator and check what the calculation will give me. Inside brackets, I'm having 45.5 minus 40. Now I close my brackets and multiply this by 1.3, which is 30% more than 100. Then I multiply it by 12. From there, I add 40 times 12, and the result that I get there will be 1127. And it looks like there's an error with my calculation. Let me come back again and check. Inside the brackets, I'm saying 45. Sorry, let me bring back the brackets. We are saying 45.5 minus 40. We close the brackets and we multiply this by 1.3. Then we multiply the result again by 12. And we test the equal sign. It gives us approximately 85.8. Then I say plus, according to Bodmer's, that's 40 multiplied by 12. And then if I say equal, I think this time around with a meaningful solution, which is going to be 565.8. So that's 565.8. Now, because it's currency, it's going to be in dollars and cents. I think that's it for number 5 and 6. All right. So take a break, then we'll proceed with number 7.